closed interval 1 to 6. I'm asking about mean value theorem. What does mean value theorem state? Eric?
That from the points A and C, or 1 and 6, there has to touch every y value between those points.
That's intermediate value theorem. We'll get to that in a second. What intermediate value theorem says, if you go from one y value to another y value, you have to hit every value in between if it's a continuous function on a closed interval. Mean value theorem states, Eleanor.
It has to be continuous on the closed interval and differentiable on the open interval.
And then you can use it, and then, what does it say?
And then it tells you wherever the derivative is equal to 0 is where the instantaneous rate of change and the average rate of change are equal.
Not equal to 0. I like that. That's actually a special case of it. Yeah, exactly. Yeah, that's actually a special case, and we might get to that in a second. But yeah, whenever, like, the average rate of change has to equal the instantaneous rate of change at one point. Okay? So let's figure out, what is the average rate of change of this function on the interval 1, 6? Well, how do you figure out what the points are? What do you do with the 1? What do you do with the 6? Okay, where? Where do I plug the 1 in to?
X less than 3.
Yeah, how do you know it's the x less than 3 one?
Because it has a y value.
Well, because x is less than 3. Yeah, it's 1. So what happens when you plug a 1 in? What do you get? 4. What happens when you plug a 6 in? Well, what rule do you need to follow? Ages, which one? Why the second one? Because x is greater than 3. Sure. What happens when you plug a 6 into this function? What value do you get?
15.
15. How do you find the average rate of change on this interval? Ellie? Yes, you do. How do you find the average rate of change on this interval?
15 minus 4 is 6.
So the average rate of change is 11/5. What is this?
Yeah.
Okay, some wacky number. Okay, so now mean value theorem states that at one point the derivative value will equal this average value. And where does it equal that in this case? Shaking your head no, Michelle. Why?
Because the derivative things are just 1 and 3.
Yeah, the derivative is just 1, and then the derivative is just 3. So what's the problem? Yeah, you can't use it. I mean, it doesn't. It's not one of the things that allows the rules. Why? It's continuous on a closed interval. We're good with that. Are you guys looking at the graph? It's a nice, clean, continuous function. But at 1.3, it's not differentiable, so that just throws. You just can't use it. Does that make sense, you guys? Okay, cool. All right, let's try 45. 45 together in your books. Less than or equal to x. Okay. And what is this problem asking me to do? Find the solution to what? What am I looking for a solution for? X value that'll what? Yeah, what this is asking for, the solution to this means what x value can you plug in to make this thing equal to 0, okay? And it wants it, I guess, on this interval, right? So it wants the x value that'll make this thing equal to 0, and you want that value between -2 and -1. How do we even start? What do you think? I don't know. Try something. It's a calculus class. I don't know. Take a derivative. I don't know. Do something. You know what I'm saying? So here, you're on this free response question, and it's like, what does this even mean? Our goal, it wants us to figure out what x value will make this thing equal to 0 on this interval. What do you think? What would you just start? We'll start somewhere. We're freestyle now. You know what I'm saying?
It's just algebra, just solve for x.
How though?
Start by moving over the one and just start isolating x.
But I don't know how to solve for a quartic. You know what I'm saying? Yeah.
I can't remember the name right now, but you know, multiply and bring down.
Oh, the sum? Does anyone know what that's called? So you can use synthetic division, sure. The numbers actually aren't very clean because they're not rational solutions. I don't think. If I remember correctly. Yes.
Are you allowing us to use our calculators?
You can look at it, but I would ask you to not use it and just say, how can we solve this? That would be the goal. Sure, because you can just stack and calculate the zero then.
It's on the interval, so why not plug in a value?
Plug in what values? Between -1 and -2?
Plug in -2 and plug in.
Okay, well let's start there. Let's start somewhere. Let's find out where is this function at -2. And what do you get? What do you get when you plug in a -2 into this? Let's see, this is going to be 16 minus 6 plus 1. Is that right? 11? -2, 11. Okay, then I plug in a -1. And I get, let's see, 1 minus 3 plus 1. I get, what do I get? -1?
Yeah.
Okay? Okay, so we're starting somewhere. I just got some points, so okay, it's telling me to find out a solution. You know, I can even graph this thing. You know, we're just having fun now. We're in the middle of a calculus test, it's a time test, we're like, hey, let's just have some fun with this. You know what I'm saying? We're just playing around. You know what I'm saying, Jackie? So at -2, we're up here. At -1, we're down here. That's what I know so far.
So you must cross it
Why?
closer to negative.
Well, I don't know how close or what, you know, because it could be, you know what I'm saying? But what do I know? I know one thing looking at that picture, if this is a continuous function. If I want to know what x value will make the output equal to 0. How? How do you know that?
Because it has to take on a value between 11 and -1.
According to?
Intermediate value there.
Yeah, according to intermediate value theorem, this is a continuous function. It's a polynomial on a closed interval. If you go from 11 to -1, you have to have passed every value on the way. So, because continuous on a closed interval, by IVT, there exists a C such that f of C equals 0. And that's how you would state that. Okay? The problem is, so that's good. So now we prove there exists at least one solution, Jesse. The problem is this thing says, prove that there's one. I mean, I don't know what this thing does. Yeah.
Just can we take the derivative and see what happens?
Let's see what happens. Is that what you just said, and see what happens?
No.
Is that what you just said? Take the derivative? What did you just say?
I said take the derivative, and I don't remember.
I think you just said it. Take the derivative and see what happens. Is that what you said? That's awesome. All right, we're having fun, right? We're just freestyling. We'll take the derivative of this, and what do we get?
4x.
Okay, so d dx, the derivative is equal to 4x cubed plus 3. Okay, I have a derivative now.
So see where that equals 0.
Okay, and so here's what's going to happen. We're running out of time. What's going to happen, this is going to equal 0, only over here somewhere. And all the way, the derivative is negative if you set up a sign chart. So if the derivative is always negative, and you have to equal at least 1, and it's always decreasing, it can never come back up. Does that make sense? If you're always decreasing on this interval, which the derivative will tell that to you, the derivative is always negative between -2 and -1, that means you can't come back up, because that would have meant the derivative was positive. You see that?